Hello friends, this video on structure of atoms part 15 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 14. The photoelectric effect which exactly shows which shows that the electromagnetic waves and the particle nature more clearly. We'll explain this also. So in this 1887, this guy Hertz performed an experiment in which electrons were ejected on certain metal. For example, there's a metal. This guy is a metal. On this guy has ejected electrons. Sorry, the beam of light. This is the beam of light actually. Beam of light. This is my beam of light, or you can say electromagnetic radiation or waves. This is a beam of light or electromagnetic radiations. This guy has. This is my metal and I have exposed this metal to this beam of light. This beam of light ejected this electron. This came out. That means it's like a ball. If you see, right, there's a ball here. Ball is hitting this metal and ball is kicking out something else from here. Right? If I have a ball, you hit a ball and when a brick come out, that means that clearly says the ball has a particle nature. Here I have this electromagnetic radiations. And these radiations are kicking out the electron from the metals. What does this prove? This proves that this electromagnetic radiations has particle nature. I hope you understand this. Also, what he did was he had this setup where this metal was there. He has put some light on this. Light is nothing but my electromagnetic radiations. Electron came out. Electron is attracted towards the positive side. And the circuit got completed, and the emitter we can see the current flowing, right? Because electron you can't see like this, right? I'm just telling that he has put he has put light on the metal and the electron came, but you can't see the electron. You have to either put some phosphorus here or the other way here was he has just put the circuit here. The circuit was incomplete, but when the light came out here, the light fall on this metal, electron came out of this, got attracted to the positive side, the circuit got completed and you could see the deflection in emitter. That was the experiment he did. And that clearly shows that the electromagnetic waves are particle in nature. So the results which he got from electromagnetic experiment which it was, the electrons are ejected from the metal surface as soon as the beam of light strikes. There is no waiting time. The moment you as soon as the beam of light strikes the metal surface, the electrons comes out. The number of electrons ejected that comes out is proportional to intensity of the light. Please note, the number of electrons that comes out is proportional to intensity is nothing but you can say the number of photons. Right? Number of photons means the more photons that you have, the more bright the light is. But for each metal, there is a minimum frequency below which the photoelectric effect is not observed. Also, if the frequency which you are giving is greater than threshold frequency, the ejected electrons comes out with some kinetic energy. Please note, the electrons which are coming out, they have some kinetic energy also. Right? And the kinetic energy depends on the frequency of light used. Please note, it doesn't depend on the number of photons, the brightness of light. Please note, the kinetic energy depends on the frequency of light used. I'll explain you why it is. Just understand this now. The frequency of the light determines the kinetic energy of electron. It is not the brightness. Right? For example, the red light has a frequency of this, of any brightness, if you put n number of photons, doesn't matter. You put on the potassium metal for hours, but there won't be any photoelectric effect. No electrons will come out. But as soon as a very weak light also, doesn't matter, very weak light, only 2 or 3 photons also, but the frequency is high here, it shines on in the same potassium metal, the photoelectric effect is observed. Thus, the threshold of potassium is this, because as I told, right, the light frequency should be more than the threshold. Correct? And please note, once again I am repeating, the kinetic energy does not depend on the brightness of the light. It depends only on the frequency of the light. In the next slide we'll explain why this happens. Let's just note that the number of electrons that is ejected, that depends on the number of photons of light you are putting. But the kinetic energy of the electron does not depend on the number of electrons you are putting. The number of photons you are putting, that depends on the frequency. It doesn't depend on the brightness, because brightness is nothing but number of photons. Correct? So I'll say kinetic energy depends on frequency of light, but the number of electrons ejected, that depends on the intensity of light. So the explanation was given by Einstein as like this. In 1905 he was able to explain that effect using the Planck's quantum theory. He tells that shining of a beam of light into metal can therefore be used as shooting of a beam of particles. Please note, here we are talking about the particle nature, that is photons. He is telling that I have this metal surface. So this light which is getting fall here is nothing but my particles, the beam of particles which is getting on this metal surface. Now, when a photon of sufficient energy strikes the electron of the atom, there is an atom here which has nuclei and some electron, let's suppose here, right? When a photon of sufficient energy strikes electron of the atom in the metal, it transfers the energy to the electron, and the electron, during the collision, this guy is kicked out. The particle, it has some energy in this, it strikes the atom, it kicks out the electron from the atom. Correct? So to kick out the electron, it should have some power, and that power is nothing but my frequency of light. So some light will have low frequency, some will have more frequency. So the frequency of the light, the intensity of the light won't define. Even if you have low frequency light, you keep on increasing the intensity, it won't matter. The frequency of the light will matter, because the frequency of the light will define the power of the light, right, to kick out the electron. And that's why if you see in the last slide we saw that we had this metal, and we are passing the low frequency light, but nothing, there was no photoelectric effect for hours. But the moment we passed the high frequency light, even a small amount of high frequency light, we saw the photoelectric effect, because that's what the threshold for every metal, they have a different threshold, because every metal you have electron tied in a different way, they have different energies, it all depends on the configuration of electrons. We'll study this in the next few slides, but just understand that pulling out of electron, the last of the electrons from metal differs. For sodium it may be easy, for potassium it may be difficult, for gold it may be all the more difficult. So those things varies based on metal. So every metal has a different threshold frequency, and the frequency of light which you pass should be more than the value required to kick out the electron. And the extra energy, for example, you have E energy you are putting here, right, and E naught energy is required to kick out the electron. The extra energy, this guy, is converted into kinetic energy of the emitted electron. We'll see that also. So greater the energy possessed by photon, this photon which is coming, greater will be transferred to the electron, and greater will be the kinetic energy. You see, this guy is the energy possessed by photon, and this guy is the minimum energy required to kick out the electron, and whatever difference is the kinetic energy. So you have more energy, photon emitting the metal, more is the kinetic energy of electron. Right? So kinetic energy of the ejected electron is proportional to the frequency of the electromagnetic radiation. Please note, frequency of the electromagnetic radiation, not intensity. Okay, frequency. Since the striking photon has energy equal to h mu, and the minimum energy required is h mu naught, the difference, that is h mu minus h mu naught, is transferred to the as a kinetic energy, and that is nothing but half mv square. And that's the same thing which I explained here. So understand, here there are two things. One is the frequency of beam or light that is beamed in the metal, and the other is the brightness of light. So this guy, frequency of light, will determine whether my electron is ejectable or not. This guy will determine whether electron will come out or not. Also, it will determine the kinetic energy of the electron. But the number of electrons emitted will not be determined as the frequency. That will depend on the brightness of the light. So if you are giving 5 photons, 10 photons, 20, 30 photons, that is nothing but the brightness of light. So if you are giving more photons, so more electrons will come out. Number of electrons. So number of electrons emitted will be determined by the brightness of the light. But whether electrons will be emitted or not, that will be determined the frequency of the light. And if emitted, what will be the kinetic energy of the electron? That will also be determined by the frequency of the light. But how many electrons will be emitted? That will be determined by the brightness of the light. Because brightness of the light is nothing but the number of photons of the light which you are beaming into this metal. Hope you understand this. Don't get confused. The brightness of the light will determine the number of electrons emitted. But before that, we'll talk about the frequency of the light. Because the frequency of the light will tell you whether the electron will be emitted or not. And if yes, what is the kinetic energy?
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.